All right, guys, I want to slowly work through a couple example problems here. So up here, I've already done a couple of them. Notice that when you look at number 1, there are 2 sig figs in the number 3.5. And when I wrote my answer 350, that also had 2 sig figs. If I were to put a decimal there, it would have 3, which is why you cannot put a decimal and have the correct number of sig figs in that problem. Now this one, if you off the top of your head knew how many kilograms were in a decagram, that is just fine to go that way. I felt it just made the most sense for most people if we could go to the base unit and then back to the other one. So remember, if you are doing this on an exam, I expect you to remember these ones. So what that means is the base unit, so for this one would be grams. As you go this way, each time you are multiplying by 10. That's why that metric ladder worked for you. Each time you go over, you move the decimal 1 place. Each time you go this way, you move the decimal 1 place the other way. Reason being, if you go this way, that is the equivalence of 10 grams. A decagram is 10 grams. This is 100 grams, and this is 1,000 grams. So 10, 100, 1,000. Now if we go this way, we get smaller. So from the base of a gram, and we go over to a decigram, that is 1/10 of a gram. Essentially, you take a gram and you divide it into 10 little pieces. Each one of those little pieces is a decigram. We go over one more time to a centigram, the C, and that is 1/100th of a gram. We go over one more time to my M, which is a milligram, and that is 1,000th of a gram. This is the amount I expect you to remember. So here I'm starting in kilograms, and I want to go to, I figured it made most sense to go to the base and then go back to deca, just for most of us, because we can see that from grams to a kilogram, there are 1,000 grams in 1 kilogram. And your double check is a kilogram is a large quantity and a gram is a small, so it takes a lot of grams to make a kilogram. Okay, then I ended up crossing off my kilograms, and I'm in grams, so I have to get that crossed off by putting a gram on bottom for a unit. And you want to see if you know how many grams are in a decagram. This guy, there are 10 grams in a decagram. So I'm going to put my 10 down here and 1 decagram on top. All right, so now I'm going to take 10 times 1,000 and divide it by 10. You can just type it on your calculator, and you're going to see you get 1,000 grams crossed off. So I'm in decagrams. But now we have to process sig figs. Because this had a decimal, I only had 2 sig figs. So this number to the appropriate number of sig figs would be 1.0 times 10 to the third decagrams. Circular box, your final answer. The reason is this has 1 sig fig, and if I put a decimal there, it would have 1, 2, 3, 4. So I can't put 2 sig figs here without putting into scientific notation. Anytime you go to scientific notation, you have to move that decimal until you have 1 non-zero digit to the left of it. So I have 1.0, and I moved it 1, 2, 3 places. All right, this next one, I have 20.0 milliliters, and I'm going to go to liters. So the first question you ask yourself is, do I know how many milliliters are in 1 liter? There are 1,000 of these little pieces in a liter, because a milliliter is 1,000th of a liter. So 1 liter is 1,000 milliliters. Milliliters on top, milliliters on bottom. I'm in the unit of liters. Now mathematically, when you're typing this in, you're just going to take it, multiply by whatever number is on top, and divide by whatever number is on the bottom. So you will take 20. I'm going to show you how to do it longhand too. Well, not longhand, but in your head. This is what your calculator will likely say when you get done. 0.02, which is 2/100 of a liter. Another way, if you're dividing by 1,000, because 1,000 is 1, 2, 3 zeros, you move the decimal 1, 2, 3. Which will give you this, but we need 3 sig figs. So I have to go 1, 2. Leading zeros never count. Trailing zeros count if there's a decimal. So 1, 2, 3 sig figs. This would probably look the neatest if you were to put it into scientific notation, which would mean I'd have to move to get one digit that's not a 0 to the left. So I'd have to move this to there. So I moved it 1, 2 to the right. So this 2.00 times 10 to the negative second liters is what I get. Now, if you go back and process it, 20 milliliters is just a small fraction of a liter, which is why you got a small number. All right, next we have 0.00039 kilograms, and I want to go to grams. So because I have kilograms on top, I know that my first conversion factor has to have kilograms on bottom. So you're going to ask yourself, do I know how many grams are in a kilogram or how many kilograms are in a gram? You should know that in 1 kilogram, there are 1,000, my base units, which are grams. There are 1,000 grams. Kilograms crossed off. I'm in grams, which is what I wanted to get to. Mathematically, you're going to take this number times this number. If you really want to, you can divide by 1, but it won't change your number. I'm going to do it on my calculator, and then I'll do it by hand to show you both. There are 3 zeros times 1,000. This is what my calculator says. Okay, also, again, there's 3 zeros, but I'm multiplying this time, so I go 1, 2, 3. So I get 0.39 grams. This had 2 sig figs, and this has 2 sig figs. So that is just fine, but you could also write it as 3.9 times 10 to the negative first grams. Either is correct. All right, number 5 is 25 deciliters to deciliters. So I'm going from here to here. So knowing your old rules, you know it goes 1, 2 to the left. So that can be your double check when you are done. But let's use this new process because this process will apply to much more than just this. I'm going to go to liters and then to deciliters. So I know I want deciliters on bottom. I know in 1 liter, 1 liter is going to have 10 of these little guys because this is 1/10 of a liter. So I have 10 deciliters in 1 liter. So deciliters cross off. Now because I have liters on top, that's not what I want to get to. I know I need to have liters on bottom. And I'm going to have deciliters on top. There are 10 deciliters in 1 liter. 10 deciliters in 1 liter. My liters cross off. I'm in deciliters. 25 divided by 10, multiplied by 10. Oops, I flipped it around. Didn't I? No. Dun, 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 dun. In 1 liter, I flipped this around. In 1 liter, there are 10 of these little things. This is a 10. That's where I'm off. Okay. Scratch that last part. I knew that because I didn't move, I was messing something up here. So in 1 liter, you have 10 of these little guys. In 1 deciliter, you have 10 liters. Okay, deciliter is big. So you're going to have more of these units than the one of that one. All right, so 1 liter is equal to 10 deciliters. 1 deciliter is equal to 10 liters. So 25 divided by 10 divided by 10. So you go 1, 2. Which is also equal to 2.5 times 10 to the negative first deciliters. It's really easy to get tunnel vision when you're going in and doing all these, so just make sure that each time you step back and check that it makes sense. For instance, does this actually equal that for each of your factors? Do your units actually cross off? So I have deciliters here, so I'd have deciliters here, liters here, liters here. And I'm left in the unit I want. When I was looking at this one, that's when I would have realized this does not actually equal that. It does now, though. All right, so let's do the next one. 0.0005000 liters. 2 kiloliters. So I know in 1 kiloliter, there are 1,000 liters. It's just like a kilometer is 1,000 meters. Liters cross off, and I'm in the unit I want to get to. You can divide by 1,000. I'm going to start by doing my calculator. 1, 2, 3, 5, 1, 2, divided by 1. And my calculator says 5 times 10 to the negative 7th kiloliters. Now I want to put this in the correct number of sig figs. This is where people struggled. Certainly you could do this in your head. I want to show you on your calculator because when people saw this, they felt that when they have to put it into the correct number of sig figs that this would change. This does not change. That's what the number is. When you do your sig figs, you're literally just putting placeholders to give yourself the correct number of sig figs. So I've got a 5 right now, but this had 1, 2, 3 sig figs. Leading zeros never count. Trailing zeros count if there is a decimal. So I have to have 3 sig figs. So 5.00 times 10 to the negative 7th kiloliters. That is your final answer.